Today's lesson: industrial production of ammonia gas. Industrial production means production of ammonia gas on a large scale. This is molecular formula of ammonia, which is gaseous at normal temperature and pressure. Now let's try to know importance of ammonia gas. Importance of ammonia gas. Ammonia gas is extremely important. It is used in different purposes, like ammonia is used to manufacture fertilizer. 80% of ammonia is used to manufacture fertilizer. Ammonia gas is used as refrigerant gas. It is used to purify supply water. Ammonia gas is used to manufacture plastics, explosives, textiles, pesticides, dye, and other chemicals. And ammonia gas is the key component of glass cleaner. Now let's see the industrial production of ammonia gas by Heberbosch process. Now the point is Heberbosch process, or simply Heber process, the process by which ammonia gas is prepared from nitrogen and hydrogen. This process is called Heberbosch process. It is named after its inventors, German chemists Fritz Haber and Karl Bosch. Fritz Haber and Karl Bosch. Now let's see the reaction in the Heberbosch process. Reaction is between nitrogen and hydrogen at the ratio 1:3. Nitrogen plus 3 moles of hydrogen. It's a kind of reversible reaction. That is why equilibrium sign is used. 2 molecules of ammonia gas are produced. At the same time, 92.2 kilojoule heat is produced. When the reaction is moving forward, then heat is produced. That means in this case, this is exothermic reaction. As it is a reversible reaction, when the reaction moves back, then it absorbs heat. In that case, it is endothermic reaction. Since this is a reversible reaction, to get the maximum product ammonia, the reaction is conducted in this way. That is, to get maximum product, iron is used as catalyst. Number 2, during forward reaction, it is exothermic reaction. That means the reaction produces heat. So removal of heat is congenial for the reaction. That is why the temperature of the reaction system is decreased. But at decreased temperature, the production rate of ammonia is decreased. That is not profitable for industry. That is why optimum temperature is set, and that is 450 to 550 degree centigrade. Number 3, 2 moles of ammonia gas are produced. That means 2 into 22.4 liters, which is 44.8 liters volume, and For the reactants, 1 mole nitrogen and 3 moles hydrogen. Total 4 moles gases into 22.4 liters. Because we know 1 mole of any gas volume is 22.4 liters at standard temperature and pressure. This is equal to 89.6 liters. That means with the production of ammonia, the volume is decreased. That is, high pressure is favorable for the reaction, and for this 200 to 250 atmosphere pressure is applied here to get maximum product. Here one thing, that is reactants and product, all the components are gaseous. That is why these compounds form a homogeneous mixture. So it is very difficult to separate ammonia from the mixture. Now let's see how is ammonia separated in Heberbosch process. Now the point is separation of ammonia gas by Heberbosch process. Now let's see a schematic diagram of Heberbosch process. First of all, this is a reaction chamber. Where there is an inlet through which nitrogen and hydrogen gas are introduced to the chamber, where this reaction happens. Nitrogen plus hydrogen, it's a reversible reaction. 2 moles of ammonia gas and heat is produced. This reaction is conducted at this condition. Iron is used as catalyst. 450 to 550 degree Celsius temperature is maintained. Number 3, 200 to 250 atmosphere pressure is maintained, and as a result ammonia gas is produced, which is mixed with nitrogen gas and hydrogen gas. Because the reaction occurs here is a reversible reaction. To separate this ammonia, this mixture of gases is sent to another chamber. The mixture of gases is sent to another chamber. This is called separation chamber. This chamber is known as reaction chamber. Here another portion is added here, which is known as refrigeration unit. This gas is taken to this separation chamber and ultimately taken to this separation unit, and here the temperature is decreased. At the temperature minus 33.6 degrees Celsius, here nitrogen, hydrogen and ammonia gas came already. And when the refrigeration unit is cooled at this temperature, this is the temperature of ammonia at which ammonia is condensed. That means condensation point of ammonia is minus 33 degree Celsius. This is the condensation point of ammonia. When the refrigeration unit temperature is decreased at this temperature, then ammonia is liquefied. This is the outlet of ammonia. But nitrogen is not decreased because condensation temperature of nitrogen is minus 195.80 degrees Celsius and condensation point of hydrogen is minus 252.87 degrees Celsius. So the temperature at which ammonia is liquefied, at that temperature nitrogen and hydrogen are not liquefied. So these nitrogen and hydrogen are returned back to this separation chamber again, and ultimately this gas is taken to the reaction chamber. Here there is a valve that allows movement of these gases from right to left, but this valve doesn't allow movement of this mixture from left to right. Now through this valve, this mixture of nitrogen and hydrogen is taken here. Again this reaction happens. Ammonia is produced. This mixture of gases is taken to the separation chamber again, and ultimately ammonia gas is liquefied, which is taken through this outlet, and ammonia collected is stored. This is the Heberbosch process by which ammonia gas is prepared and collected. This ammonia gas is dissolved in water to make important ingredient of glass cleaner. This is schematic diagram of Heberbosch process. Schematic diagram. This is all about industrial production of ammonia gas by Heberbosch process. Thank you very much.